Let's go on to number 3. Fill in the table showing the number of seeds planted compared to the number of seeds that started to grow. So we see our X value here is the number of seeds we plant, and then the Y value is going to be the number of seeds that grow. Now, let's continue to number 3. Fill in the table showing the number of seeds planted compared to the number of seeds that start to grow. Here we see our table with the X value here, number of seeds we plant, and then the corresponding number of seeds that grow. Now, to fill this out, we're going to need this information back from the very beginning of the first part, where it says that for every 35 seeds Angel plants, only 7 grow. We're going to use that to find our constant proportionality. And once we got that, we can fill in this whole chart. We know our equation for our constant proportionality, which just means how y and x are related. And if we know that, we can fill this in. K equals y over x. Our y is the number of seeds that actually grow. They gave us this information, 7. And only 7 grow when there are 35 that are planted. 35. I'll label this for clarity. 7 grow, 35 are planted. Our y, number of seeds that grow. Our x, number of seeds that are planted. So we have 7 over 35. We can definitely simplify this. Let's divide the top and the bottom by 7. And you're going to get 1/5. And we can leave it like that. K equals 1/5. Now, a few ways you can use this to fill in this chart. I'll explain one way briefly, and then I'll show the other way. One way is, once you got 1/5, if you multiply the K value by any X, that'll give you the Y. For example, 0 times 1/5 is 0. 10 times 1/5 is 2. Okay? To go in reverse, here they don't give you the X, but they give you the Y. You would do 4 divided by 1/5. You'd have to do keep, change, flip, and you'd end up getting 20. The more thorough way you can show is just by using this to craft the equation. Y equals kx. Of course, we already got our k, so it's y equals 1/5 x. And now, whether they give you an x value, you can plug that in, or they give you a y value, you can plug that in. Let's show the process for solving for our x value here. So they gave us a y, which was 4. So we'll plug in a 4 there. 4 equals 1/5 times x. But we got to solve for x. So let's divide the top and the bottom by 1/5. 4 divided by 1/5. Come over here. Let's just keep, change, flip. And you see it's going to come out to be 20. And by this point, you're probably noticing they're starting to form a pattern. And in a proportional table, you will see that. So once you see that pattern, and I might just verify like one more. Let's do one more, and then we can just fill out the rest of the pattern. So 30, that's the x. Make sure you plug it in the right spot. Let's go back to our equation. Y equals 1/5 x. To give us 30 for x, let's plug that in. 1/5 times 30 equals y. This is going to become 30 over 1 times 1/5. That's going to give you 30 over 5. Of course, if you simplify, you divide the top and the bottom by 5. You're going to get 30 divided by 5 is 6. 5 divided by 5 is 1. So you get 6 over 1, which is 6. I found that the y equals 6. And of course, the x here was 30. So that's our point there, 30, 6. And look at that, 30 and 6. And let's just zoom out and look at the pattern now. 0, 2, 4, 6, 8, 10, 12. Go on the top. Notice how the x's count by. 0, 10, 20, 30, 40, 50, 60. That's a characteristic of proportional tables. You'll be able to do that process on a proportional table. Now, each of these are points. Let's just plot them. 0, 0. The first point. 10, 2 is the next one. Make sure you're going x, comma, y. Remember, this is our x-axis. This is our y-axis. 10, 2. So go to the x first. 10 and up to 2. That's 10, 2. Cool. 20, 4. 20 and 4. 30 and 6. 48. 50, 10. And 60, 12. And then connect all these lines. Missed one there. There we go. And let's go to the final portion.